Hello guys and welcome back to the reaction zone. In today's lesson, we're going to look at how to balance the equation on the board using oxidation number method. The first thing to do with this equation on the board is to write the oxidation number of all the atoms in all the elements or compounds in this equation. Copper has an oxidation number of 0, hydrogen has an oxidation number of +1, nitrogen here has an oxidation number of +5. Each of these three oxygen atoms has an oxidation number of -2. Copper here has an oxidation number of +2. Nitrogen here has an oxidation number of +5. Oxygen here has an oxidation number of -2. This nitrogen has an oxidation number of +4. Oxygen here has an oxidation number of -2. Hydrogen here has an oxidation number of +1. And oxygen has an oxidation number of -2. The essence of doing this is to see the elements in which there is a change in the oxidation number, whether increase or decrease. Because let us not forget that oxidation involves increase in oxidation number and reduction involves decrease in oxidation number. So the essence of assigning oxidation numbers to all the elements in the chemical equation is to know which of the elements is characterized by an increase in oxidation number and which one is characterized by a decrease, and which ones have the same oxidation number in moving from the reactant side to the product side. Now, when you look at this clearly, you discover that there is an increase in the oxidation number of copper from 0 here to +2. You will also observe that there is a decrease in the oxidation number of nitrogen from +5 to +4. So we're going to bring out these two scenarios, which is copper to give us CuNO3 equation 1, and then we're going to have HNO3 give us NO2. You can see that this copper here is 0, copper here is +2, nitrogen here is +5, nitrogen here is +4. So this is our equation 2. In the first one, there is an increase in oxidation number. In this one, there is a decrease in oxidation number. So the next thing we will do at this point is to ensure that the increase in oxidation number as well as the decrease are equal. Before we do that, it's important for us to state that increase in oxidation number of copper is equal to 2 units per molecule. And then decrease in oxidation number of nitrogen is equal to 1 unit per molecule. So what we're going to do at this point is to ensure that the increase in oxidation number for copper as well as the decrease in oxidation number of nitrogen are made to be equal. And the only way to make them equal is to multiply equation 2 by 2. So equation 2 multiplied by 2 will give us 2HNO3, give us what? 2NO2. So this becomes our equation 2. Now that we've done this, we can add equation 1 and equation 2 together. So when we add them, we have copper plus 2HNO3 to give CuNO3 2 plus 2NO2. And then we're going to have to add this water that is in the original equation here. Now this equation is still not balanced yet. What we'll do now is to check if atoms other than oxygen and hydrogen are balanced. Copper is 1, copper is 1, copper is balanced. Now when we look at the nitrates, you have 2 here, 2 here, making 4. And then you have just 2 here. So what do you do? At this point, we can remove these 2 and add 4. So you have 4 nitrates here, 2 nitrates here, and 2 nitrate ions, so making 4. Now let's see if oxygen and hydrogen are balanced. Oxygen here is 12, oxygen here is 6, plus 4, 10, plus 1, 11. So if we decide to add 2 here, for instance, let us check if oxygen is balanced now. Oxygen here is 12, oxygen here is 6, plus 4, 10, plus 2, 12. Let us also check if hydrogen is balanced. Hydrogen here is 4, hydrogen here is 4. And nitrogen, 4, nitrogen here 2 plus 2, that is 4. So that tells you that everything is balanced. And this is the balanced chemical equation using oxidation number method. Thank you very much for watching and see you in the next lesson.